All right, thank you for the introduction, Carmen. She's a bit right. I'm going to scare you a little bit, but it's a good thing. You have to be a little bit scared just to know that you don't have to ignore security and you have to actually take care of it. Today I'm going to talk about security in Angular applications. Very specifically, I'm going to talk about one issue, which is cross-site scripting. Some of you probably know cross-site scripting, maybe a little bit, maybe a lot. Some of you have no idea what it's all about. Let me first give you the scary part. Cross-site scripting is actually really, really powerful. So to give you one example, the Apache Foundation hosts a lot of open source projects. A couple of years ago, they had a cross-site scripting vulnerability in their bug tracking software. So somebody exploited that, targeted an admin, and he even made it as far as user access to the repository server. So they caught him just in time before he had a root exploit to essentially compromise all code repositories hosted on that server, all through an XSS vulnerability. And a second example of how scary these things are is the BEEF framework. BEEF stands for Browser Exploitation Framework, and essentially it's a toolkit you can use to hook a browser. And once the browser is hooked, you can start running exploits in that browser. So you can, this is an example of capturing an image from the webcam if the user has given that permission to the application. But it can do screenshots of the application, it can run arbitrary code, it can do essentially anything you want. There's even a plugin to run browser exploits against the browser. So in case you have a vulnerable Firefox or Chrome, this thing will run an exploit against it, exploit it, and you will have the possibility to install malware on the user's machine, just by visiting a web page that contains a cross-site scripting vulnerability. So by now, you should know cross-site scripting really dangerous, but the good news is I'm going to talk about how to fix these things, and you'll actually see that it's a lot easier than you might think to make sure you don't have these vulnerabilities. Maybe a very small word about myself. I'm from the University of Leuven. I'm a Belgian. I actually did a PhD in web security, and since then I've been giving trainings on web security. So I give training courses to teach people how to build secure applications. And the main reason I do that is because I don't build the stuff that people or thousands or millions of people use from day to day. You guys do. I know about security. You guys sometimes know a bit about security. Sometimes you know not so much about security, which is okay. Everybody has his own thing. So I'm going to teach you how to build secure applications, and I'm going to give you a small part of that here today in this talk. To talk about cross-site scripting in Angular, we need to talk about the past. We need to take you back 5, 10, 15 years to a thing called PHP applications. The very first thing where you had HTML and you mix it together with some output in PHP. This is a very good example of a potential cross-site scripting vulnerability. So what you have here is you have some output, you get a username from somewhere, it's typically untrusted input, and you put it directly into the page. So what happens? If I enter my name there, it will show in the page as my name, which is a good thing. You have some functionality, and as a developer, you might be happy with this, it works, let's move on. However, if somebody comes along and tries to do some sneaky things, he could do something like this. And insert a blink tag, and the thing actually starts blinking. Well, whether you consider it malicious or not, that's up to you. But somebody might come along and do something even worse. He injects a script tag. This script, by the way, the hook is what you need to hook a browser with the BEEF framework. If you do it like that, you'll see actually the username being shown in the page. Everything looks nice, but in the background, if you would look at your network tab, you'll see that the browser is polling this BEEF framework for commands to execute on behalf of the attacker. And this is essentially the crux of cross-site scripting. This is what it's all about, and this is why it's so dangerous. It allows the attacker to do anything he wants. So how do you defend against that? Well, traditionally in these server-side applications, you would need to escape or encode the output that you're putting into the page. So as a developer, you know username is untrusted. It might come from anywhere, so maybe it's not the best thing to put it directly into the page. So in PHP, you would use this thing called HTML entities. And what it does is it does something like this. If you inject a blink tag there, it will escape it. It will render it harmless. The browser will render it instead of essentially parsing it and executing it. That's the very basis of cross-site scripting. This is a crash course on how to create vulnerabilities and prevent them from happening. So the real question is, why do we have these things today? Why are so many applications riddled with these kinds of vulnerabilities? And they happen to the best. They happen to Facebook. They happen to Google, to people who know how to build secure applications. Well, the reason is, it's obviously not as simple as something like this. You have something like that. You have everywhere in the page, you have untrusted data. You put it everywhere. And what's even more important, you put it in all kinds of different contexts. So you have a context within an HTML element. We already covered that. You can also put untrusted data in CSS code. You can put it in JavaScript. You can put it in attributes. And all of these locations require something different to mitigate vulnerabilities. If you encode an HTML tag and put that output in CSS, context, it doesn't mean anything, HTML tags there. There are other exploits using CSS to do harmful things to a page. And this whole setup is exactly the reason why it's so difficult to protect against cross-site scripting. If you look at this problem from a bit more of an abstraction level, I come from an academic background, so that's essentially what we're trained to do. You'll notice that this is very familiar to another problem we have. You'll notice that this looks a lot like something we had about 20 years ago, and we still have today, called SQL injection. In a SQL injection attack, you have the same problem. You have a confusion between data and code, because you have a SQL query, you put some untrusted stuff in there, and you send the thing off to the SQL server, who has no idea anymore what you intended to do, and he will execute the injected code as well. Same thing happens here. The server actually knows very well which parts of the page are trusted and which parts are untrusted, because it puts the data right in there. And that's why the server is responsible for making sure that it's protected against cross-site scripting. You ship this whole thing to the browser, the whole page to the browser, and essentially the browser loses all context. So essentially you get the same story as a SQL injection problem. The browser has no idea what part of the page was supposed to be there and what part of the page is injected by the attacker. And that's essentially one of the reasons why defending against cross-site scripting is so difficult. And that's unfortunately one of the consequences of how the web was designed in the early days. If you look at SQL injection, if you look at the protection mechanism against SQL injection, separating data and code and treating them differently, you might think of a solution to combat cross-site scripting in these modern frameworks. There's this beautiful framework called Angular, you probably heard of it. It does something like this. It allows you to ship a template to the client, and in the template you inject data afterwards. And the real nice thing about this is, if somebody does something like this, the script tag here is simply shown on the page. It's not executed, it's shown. And the reason it does that is because Angular is actually able to separate data and code for you. What you do is you write your code, you write your application, your templates, your JavaScript code, you package it up, you send it to the browser loads it, browser fetches some data from an input, from an API, from anywhere essentially, and Angular will put it in the right place. At that moment, Angular knows very well that this template is trusted, but this username part is very untrusted. So it will automatically escape this data for you. So essentially, if you use simple binding with double stashes here, Angular will protect you against cross-site scripting out of the box, which is very good news for people who never heard about cross-site scripting. So that maybe takes the edge off of the scare from the beginning. So this is actually a very, very powerful feature of these client-side frameworks. However, sometimes, you probably notice sometimes you actually want some HTML in there. So if you want to put a blink tag in there, I don't know why, but let's say you do for some reason, Angular won't actually allow you to do it. It will simply, again, render this directly instead of processing it as you meant it to be. So there's another solution you can do there. Angular is a bit flexible there. Escaping is not mandatory. You can use something called sanitization. Sanitization is a radically different approach. Instead of taking out the encoding the harmful characters, it will simply take out anything that's harmful. So you can do it by binding something against inner HTML, for example. And if you do it like that, and you inject the blink tag, it will be shown on the page. So this means that Angular doesn't consider the blink tag to be malicious, because it's allowed to be rendered. For the record, I didn't check this whether this is actually the case. I just made it on my slides, so maybe somebody should check whether Angular actually allows that to be in there or not. But the real story, or the real point I want to make here is if somebody injects this hook using a script tag, and you put that through the sanitizer, it will be removed. Angular will parse the piece of data you're trying to bind there. It will see that there's HTML in there. It will investigate, is this something I want to allow or not? And if it's not, I'm going to take it out. This means that things like script tags are taken out. This means that things like inline event handlers, like an error on an image, is taken out, but the image is preserved and will be allowed to be present in the output. So this is a very, very powerful mechanism. So actually, this is a very positive story so far. Angular auto escapes for you. Angular auto sanitizes for you. So what else can I talk about? Well, maybe a small warning. If you bind HTML, do it the Angular way. Don't try to get hold of these low-level DOM APIs and try to do it directly, because then Angular will not be able to protect you, of course. And the second warning I want to give here is there's an option to bypass the sanitizer. There's a way to tell Angular that you specifically trust a very specific string to be safe. Essentially, this used to be a big problem in Angular 1, because Angular 1 didn't automatically sanitize. It gave you an error. An error caused people to Google for it, find Stack Overflow posts saying that you have to use these trustless HTML functions and use it to sanitize your content. The problem is these functions don't sanitize anything. They simply output it directly, meaning that people using a sanitizer from Stack Overflow advice actually open their entire application up to cross-site scripting. So one of the changes in Angular 2, these functions still exist. They have a very specific use case. So if you don't know what the use case is, stay away from them. And they also renamed the functions to bypass security trustless HTML. So if you use a function called bypass security trust HTML, that should be kind of a clue that you're doing something that you might want to check into what it actually means before doing that in your application. And that brings me to the last point of this topic. Essentially, you'll always have people that think that they know better, that think that they understand XSS in all their merits, and that consider it to be a good idea to disable the sanitizer. I want to give you this as a warning. Don't do this. This is a thread on Angular security on GitHub, by the way. You can look it up. This guy is like, yeah, you can disable sanitizer using this code. I don't need it. My inputs are safe. I'm fully aware that they're safe. People from Angular are arguing against him, like, don't do this. This is a bad idea. Cross-site scripting experts are like, dude, absolutely don't do this. What are you thinking? And he keeps going on. Yeah, I know it's safe. It's safe. It's safe. So I didn't even include the code here. I don't want this in my slides. Don't ever disable it. It's a very, very bad idea. If you need to disable it, you're doing it wrong. That's essentially what it boils down to. So the takeaway point number 1 from this presentation is essentially Angular protects you against cross-site scripting out of the box. This is a very good thing. The only thing you need to do is get out of the way. Don't try to work against it. Don't try to force Angular to actually do something it's not supposed to do. Benefit from this protection and make sure that your applications are safe. By the way, I've included a small overview of what I talked about here, but it's for later reference. I'm not going to go into detail about that here. The slides are on my website. They're on Twitter, so if you want to grab a copy of that, feel free to do so, and you'll have the overview for later reference as well. A second topic I want to mention is this small problem where you can trick Angular into misbehaving. And it's essentially a problem that we see a lot when you try to combine Angular with a traditional web application. So a lot of you have worked on traditional applications, PHP applications, Java applications before, that do server-side rendering. The problem is, if you want to use Angular, these applications are typically not very compatible with that, and your boss probably won't approve a full rewrite simply because you want to use Angular instead of the traditional technologies. So what you typically try to do there is you try to merge those two together, and you still want to benefit from Angular even though you still have some PHP or whatever running in the background. This is a typical scenario. You have your PHP application. It still does some output into the page. You have XSS protection there, very good, and you also load the Angular library. However, this thing leads to a very small problem called template injection. So essentially what can happen is somebody can come along, inject a username with some Angular statement behind that, and the server will actually echo that back in this value here. So the server outputs this, which in turn renders this, pops up an alert box in this case. So you got away easy. It could have been a script that does something much more malicious. And what's really happening here? Well, the problem here is that the server does its XSS protection, but the server has no idea that this thing, which is essentially a static string for a PHP parser, if he parses this, he's like, yeah, I don't know what that means. It's not HTML, so it should be safe. So he has no idea that Angular will take this string on the client side and actually take that and execute it and make it executable script. So that's definitely one of the problems. They tried to prevent that in Angular 1. So researchers came up with this. They worked with Angular to try and fix that. They implemented this expression sandbox to try and prevent you from breaking out of this Angular environment and getting a hold of global functions. But they eventually gave up because people kept finding bypasses against it. They come up with the most crazy JavaScript code you've ever seen, which eventually returns this pop-up dialog, and you know, like, damn, another bypass. So eventually they tried. They fixed it and they fixed it and fixed it, and eventually they said, yeah, there's no point in doing this anymore. It's too much work. It's too complex. Just don't combine Angular with server-side code. Otherwise, you're going to have a bad time. That's essentially what it comes down to. In Angular 2, the same problem exists. But Angular 2 offers something called ahead-of-time compilation. And Igor already mentioned this this morning. And we talked a bit about this yesterday. And essentially, the really powerful thing of this feature is that it compiles your templates on the server side. So you build your application, you compile it into JavaScript code, and then you ship it to the browser. And when you have some bindings instead of the curly braces, you have some JavaScript code being sent to the browser. And the really powerful thing here is that if somebody injects something in your template, it's already too late because your template has been processed and has been compiled already. This means that the browser, when you load Angular in your browser, when you have compiled your application, it will not start looking for these curly braces, it will not encounter something injected by the attacker, and it will not trigger a script execution attack, which is really, really cool. Again, an Angular feature helping you to build better and more secure applications. Takeaway point number 2. If you want to get rid of this template injection, use this ahead of time compilation. By the way, ahead of time compilation is also wicked fast and has multiple other benefits, so it's definitely something you want to start using when you build Angular 2 applications. And that brings me to the third part of the presentation. And the third part is actually, in my opinion, one of the coolest parts. It's about how to handle a cross-site scripting vulnerability when it's there, when it's even too late, when it's being exploited. And the real question is, if cross-site scripting happens, which eventually it will, some of your developers will make a mistake. That happens. Somebody will use this trustless HTML in the wrong way. Maybe there's a bug in Angular which allows something to sneak through to the sanitizer. These things happen. So when they happen, is everything lost? Is Angular on fire? Should you just give up? Well, it depends. You can either just let it burn down and call insurance, or you can install a sprinkler system to prevent the fire from happening or to put out the fire when it actually happens. And in this case, a sprinkler system is content security policy. And content security policy is actually a very new mechanism in the browser. It's a browser security policy that you can configure from the server. So the server can give the browser a security policy and say, enforce this thing on my application and make sure that my application is protected. So essentially, you give it in a response header or the meta tag. And what CSP does is CSP, by default, applies 2 different protection mechanisms. The first is it prevents remote scripts from being loaded unless they are whitelisted. So if somebody injects this evil script from evil.com, unless it's explicitly whitelisted by your policy, which I don't recommend for things like evil.com, it will not be loaded. You will get an error in the browser saying this thing is not whitelisted, I don't know it, I'm not going to load it. And the second thing CSP does is it doesn't allow inline script blocks to execute. So this means if an attacker injects something like this, it's called inline script because the script is right here, it's not remote. CSP will simply block it and it will not execute this. So probably some of you are thinking like, yeah, that's kind of restrictive. How will that work in practice? That's a very good thought. Essentially, it doesn't work on traditional applications. Think back to the PHP story. People building PHP have probably all these things put everywhere in their applications. But if you think about an Angular application, it's actually very compatible. Angular has templates, HTML, you don't load scripts in there. Angular has JavaScript files, okay, that's fine, you can load them and whitelist them. And other than that, other than maybe your main page, you don't have all of these dependencies that you might need to take care of. So a small example, yesterday I made this very small demo application which doesn't do anything except load some files to show you how CSP works. And I configured this content security policy. And when you load it like that, you might think, if I say everything will work, you might think it works, but it doesn't. It gives you these browser errors, quite a lot of them actually. And these are typical CSP errors. So let me walk you through them to tell you what they mean. The first 2 are because we load some stuff from Cloudflare. So we have some script files from Cloudflare. It's jQuery and Bootstrap, which I don't use because the application doesn't do anything, but they're there anyway. And the second part is about unsafe inline scripts, because we have a script block here, which is also prevented from running. Let's tackle these 2 problems separately. So let's talk about remote scripts first. Adding the Cloudflare CDN to your whitelist is essentially enough to prevent these errors. So essentially what we tell here is, we tell CSP, I'm going to load some scripts from Cloudflare, so allow these things to go through. And the host matches, so CSP will actually allow these scripts from being loaded. Awesome. Sounds easy enough, right? Well, it can be a bit more complex in a real application, but essentially that's what it boils down to. That's what people have been doing for 2 years. Until this summer, Google investigated CSP. They tried to use it. It didn't work very well for them internally. And they actually analyzed existing CSP policies. And they found a lot of people whitelisting CDNs. And they also found that that's a very, very bad idea. And one of the reasons is they built this tool to evaluate your CSP policy. And one of the reasons or the problems with whitelisting a CDN is that when you do so, you allow anything on that CDN to be included in your page. And that means if one of these scripts on the CDN is a JSON-P endpoint, you can simply call it and make it execute scripts on your page, which is definitely problematic. And the second problem you have with whitelisting CDNs is kind of ironic. It's because of Angular. And it's essentially the template injection trick. So a CSP bypass with Angular is an application which doesn't even use Angular, but uses CSP and whitelists a CDN. What an attacker can do is it can load Angular from that CDN. It's whitelisted, so it's allowed. And then inject some some text that will trigger Angular to execute or to process the template and execute it as script code. So that's essentially a kind of an ironic bypass to talk about on an Angular conference, but that's what happened. And they scanned the Google index and they found that 95% of CSP policies are actually very easy to bypass using these tricks and mechanisms. And that's definitely problematic. So the message here is don't whitelist CDNs. What you can do is you can whitelist explicit files. So you could go up to the file level and say, I explicitly want to include this jQuery file. That would be one thing. The other thing is you can use nonces. And a nonce is actually a mechanism in CSP level 2, which is also has been available for a couple of years. And a nonce is a random value, which is probably something more random than super random. So it should be a long and random value that you include in your CSP policy. And you include the same nonce in your script files, where you essentially say, because the nonce is there, I have put it there, and because of that, you can trust the script to be intentionally included, and you can load it from the CDN. That's how they work. So, very important thing here, the nonces should be fresh and random on every page that you send out. Otherwise, the attacker would be able to know or learn what a nonce is and inject the script with a valid nonce. So, awesome, nonces, very cool. They also work for inline script blocks. So you have this script block here, simply add the nonce as an attribute to the script tag, and the error also goes away because the nonce is already in the whitelist of the CSP policy. Very, very cool. So what else can you do here? Let's talk about including remote components, because loading some files from a CDN, that's one of the fairly easy use cases with CSP. Loading a Twitter timeline is a lot more complicated. To load a Twitter timeline, in case you haven't done that before, you need to configure this widget on Twitter and you get this small piece of script to include. It's an inline script block. That's okay. You can put a nonce on that and you can allow that to be included. But then Twitter tries to load all of this crap, and if you would want to make this work, you would need to whitelist these CDNs from Twitter, which is, they contain a lot of JSONP endpoints, by the way, so it's a very bad idea to do it like that. The problem is these scripts are loaded dynamically. This Twitter script loads this and injects this into the page, so there's no way for you to put a nonce to these script blocks, and that makes it a bit difficult. But together with their analysis of CSP policies, Google came up with this new mechanism to deal with that, and that mechanism is called strict dynamic. And strict dynamic, essentially, this has not changed. We still have our nonces here, but what strict dynamic does in the policy here, it essentially tells the browser that if I have included a script with a nonce, or a hash, but that's something we can talk about offline, if I have included a script with a nonce, I actually trust that script. And I also trust what that script is going to do because I have put it here, and I would have needed to whitelist everything it does anyway. And if the script wants to do something malicious, by the way, it can do it already from its own code. So it doesn't need to load additional code for doing that. So if these conditions are met, if it's nonced, and if strict dynamic is there, simply trust what the script wants to do and allow it to load additional resources as well. So for the Twitter timeline, by adding strict dynamic, we can put the Twitter code here. That's a mistake on the slide, by the way. There should be Twitter code there. It's allowed to load additional resources from these Twitter CDNs, and it is able to load this Twitter timeline. And this is actually how Google sees CSP evolve. They say whitelists are broken, people cannot get them right, but with strict dynamic, we actually have a fairly simple mechanism to enable these things in your application, and you can allow additional script files to be loaded. And you see that evolving into this thing called a universal CSP policy, or a strict CSP policy, where you don't need to configure too much while still being able to enable CSP and benefit from this protection. There are a few new things here, which I may want to discuss very briefly. So this is the header you set. The first thing they do is they set object src to none. And this essentially means that you do not want to include Flash or Java applets, which is a very sane choice. The reason you want to do that is because a Flash file can have the possibility to execute scripts. So if somebody injects a malicious Flash file and sends it some script code, which it in turn executes within your page context, you're still screwed. So by setting this to none, you make sure that that doesn't happen. Then we have the script src. We covered that. The gray ones I will talk about in a minute. And then the final part is also very cool. This is report URI. And that's a feature where you can tell the browser to send you a report if a violation of your CSP policy is detected. So let's say you deploy the CSP policy, everything works, everything is protected. Awesome. Then someday a user comes along and an error happens, a violation happens. That might be something you missed, something you needed to whitelist. That might be an attack happening in the browser. The user will see this, well, he won't see it, but he will get this console warning, which he probably doesn't see because he doesn't have this open. For you, it's not very useful to have a console warning on the machine of the user. So with CSP, you can instruct the browser to send you a report to an endpoint you control somewhere. So you essentially get this JSON file being sent there, containing the details of this was a policy, this was a directive that has been violated, this was the file that violated that, and it was this piece of script code that actually did that. And that gives you a real insight into potential attacks happening on the user side, and that's actually a very, very powerful feature. So, to conclude, let me talk about these grayed out things here. These grayed out things are there for compatibility reasons. So, this universal CSP policy, it works, but it depends on the browser whether it works well or not. So, let me show you. If you're running Google or Firefox 52 or higher, I think it's about to be released, I'm not sure. I'm not a Firefox user, so I don't follow that very closely. If you have these browsers, they know that they have this support for strict dynamic, the latest features, the latest CSP stuff. So what they do is, they actually enforce this policy for scripts. And that's the nonce part, so everything with a nonce will be trusted and allowed. And that's the strict dynamic part, and that's essentially everything that a nonce script tries to load will also be allowed. And if you do it like that, you have protection for remote scripts. Nothing is whitelisted, so no remote scripts will ever be loaded unless they're nonced. Great. And you have protection against inline scripts, because inline script blocks will be blocked. By the way, the unsafe eval, this feature re-enables the use of eval, which CSP disables by default as well. Google puts it there because some libraries depend on it. If you strictly use Angular 2, you don't typically need it. So you might want to get rid of that if you want to. I just wanted to give you the full policy as Google sees it, because just for completion, for completeness. Okay, Google and Chrome, awesome. Unfortunately, not the only browsers Chrome and Firefox, not the only browsers around. If you have Safari or Opera, they're still a bit behind. They support don't support level 3, but level 2. And essentially, they will enforce this policy. And what this means is, it gives you inline protection, because inline scripts will not be executed, but they fall back to a whitelist. And a whitelist, in this case, is fairly liberal. It's all HTTPS scripts and all HTTP scripts, essentially any script on the internet. The reason they do it like this is simply because of compatibility reasons. If they would not have put this in the original policy, by the way, strict dynamic causes these whitelists to be ignored. That's why Google doesn't enforce them, or Chrome. But Safari needs them because it doesn't know strict dynamic. So it would prevent Twitter from loading additional scripts, and it would have broken the application, which is not something you want. So this policy, you can deploy it without breaking your application, and the newest browsers will actually benefit from that protection. The two more browsers we need to talk about, that's IE and Edge. By the way, Edge is doing a lot of effort security-wise, so I'm not here to bash them. But on CSP, they're lagging behind. They're still on version 1, so they don't support these nonces, and they don't support strict dynamic, which means that this is the policy that will be enforced. Unsafe inline does exactly what you might think. It enables all inline scripts, and this whitelist enables all remote scripts. So you actually don't get any protection here, but you still don't break anything either. So that's the major benefit of this policy. It allows you to do this without breaking anything. Brings me to the third takeaway. Third takeaway, CSP allows you to lock your application down. CSP seems very scary in the beginning. If I would have told you this without all the context, you would be like, I'm never going to touch that. But if you have an Angular application, this is actually something that is fairly doable to enable. It largely depends on your context, of course. If you use a lot of crappy external libraries, this might be more difficult than I presented here. But if you have a very self-contained application, it's definitely very, very powerful and very easy to enable this policy on your applications. So definitely something you should look into. By the way, a final note on CSP, they also support a report-only mode, allowing you to deploy your policy, get violations, but not block anything if something goes wrong. So doing this allows you to dry run your policy, essentially. You can configure a policy, configure it on your server, send it out to users, and simply watch your reporting endpoint for potential reports. If they don't come in, it's a good thing, because you don't have any violations. If they do come in, you haven't blocked anything, so you haven't broken anything, and you can fix your policy before actually flipping the switch to blocking mode. Again, that's what I covered here. Brings me to the conclusion. Takeaway number 3, CSP, very powerful, lock your application down, essentially the sprinkler system against the fire, in this case, a cross-site scripting vulnerability. Takeaway 2, ahead of time compilations gets rid of template injection attacks and makes your app a lot more fast and smaller, which is a very good thing. And takeaway number 1, Angular does a very good job in protecting you against cross-site scripting. The only thing you need to do is get out of the way and don't shoot yourself in your foot, essentially. That was the main message of my talk here today. Now, I've given you some information. I told you about security in Angular. Now it's up to you. You actually have to secure your applications. You have to look into CSP, start deploying CSP, and start to take care of security in your applications. I provide a lot of information, not only on Angular and CSP and cross-site scripting, but essentially I cover the whole web security landscape. So follow me on Twitter or follow the mailing list if you want to get some overview of recent events. And share this information among others. If you deploy CSP in your Angular application, please share this with your fellow developers. Talk at a meetup, present on how you did this, and help other people to build better and more secure applications. That's essentially my main message here today. Thanks for listening. I'll be here all day, so feel free to talk to me during a break about security, about this talk, about anything else. I love talking about food as well, so please do that too. I definitely don't mind. And thanks for listening, essentially.